Okay, class, picking up where we left off at. It says find the sum of the angles of the following hexagon by first dividing the quadrilateral into 4 triangles as shown. Notice how 4 triangles are created by starting at one vertex and drawing segments to the other vertices in the polygon that are not connected already to the vertex you started with. So we start here. We go to this point, and this point here. We don't include these 2 points here because this is part of the vertex. So if you notice here, this cuts this into 4 triangles. It says the sum of the angles in the hexagon would be the same as the sum of the angles in 4 triangles. So we'll do 4 times 180, and that would give us 720 degrees. Now, it says here, the sum of the measures of a polygon's angles. Do you notice a relationship between the number of triangles you can create from one vertex and the number of vertices in the polygon? The sum of the measures of the angles of a polygon with n sides is, parenthesis, n minus 2 times 180 degrees. So it says find the sum of the measures of a regular triskaidekagon, which is 13 angles. So we have n minus 2 times 180. Now n represents how many sides we have, which is 13 in this case, times 180 degrees. 13 minus 2 is 11 times 180 degrees. Now we can take our calculator and take 11 times 180. And that will give us 1,980 degrees. It says here, find the sum of the measures of the angles of an octagon. Now remember, an octagon is 8 sides. So we'll take n minus 2 times 180 degrees. So it'll be 8 minus 2 times 180 degrees. So it'll be 6 times 180. So we'll take our calculator. 6 times 180 should give us 1,080. So our final answer here would be 1,080 degrees. Now, it says find the measure of one angle. Find the measure of one angle of a regular nonagon. Okay, now remember, a nonagon, if all angles are the same and also all sides are the same. Okay, so this is what we would do. We would take our formula here, n minus 2 times 180. Remember, a nonagon has 9 sides. So this would be 7 times 180 degrees. So we'll put that in the calculator. 7 times 180. And that gives us 1,260. Okay, now that is how much it would be for all of the angles. But they asked specifically for one angle. So what you would have to do is take this value and divide it by 9. So we would take 1260 divided by 9. So that'll give us approximately 17.7. So it'll be 17.7 repeating 7 degrees. And that is the final answer. Now, we scroll down here. We come to our next angle. Okay, class, I had to go back here a little bit. As you see, we have 17 point repeating 7s. That's incorrect. I looked at the video again and noticed that I did not type in 1,260. I believe I just typed in 160 in error. So I would type that in now, 1,260. And I need to divide that by 9. And that will give 140. So our answer here should be 140 degrees. That's the answer to one of the angles in this example. Now we go to the next example. It says if the sum of the measures of a polygon is 1,620, how many sides does the polygon have? So what we could do is this. We could take n minus 2 times 180 degrees is equal to 1,620. Now, the first thing we would do is to divide each side by 180. And we would add n minus 2 is equal to. Now, we could take our calculator. We would take 1,620 divided by 180, and that gives us 9. So this is 9, and then we will add 2 to both sides, and n is equal to 11. So it has 11 sides, and that is our final answer. Now, we scroll to the next page. It says the measure of an exterior angle of a polygon. An exterior angle of a polygon is formed by extending a side of the polygon. The measure of the exterior angle is the supplement of the interior angle. Now remember, our supplements mean that the two angles added together will give you 180. So this exterior angle and this angle here together gives us a 180 degree angle. It says the measure of the exterior angle is the supplement of the interior angle. Now it says here, the blank of sum of the measures of the exterior angles of a polygon. The sum of the measure of the exterior angles of any convex polygon is 360 degrees. So what this is saying is this here. Let's just say that this is a regular polygon. And we know this breaks up into 3 triangles. So each one of these angles would be 108 degrees. All of these would be 108 degrees. Now if you notice, it's 5 angles. So then we would end up with 5 exterior angles here. So this would be 72. We could say 72. We could put that here as 72, 72, and 72. Okay, now, if we take all of these exterior angles and add them up, they should equal to 360. So we'll take 72 times 5. And this will give us, let's see, that's 10, carry a 1. 5 times 7, 35, plus 1 is 36. So it's 360 degrees. And this is what this statement is meaning, and we're done.